Hello everyone, this is Dr. Mihir Shah once again with another video. In this video, we are going to learn how to solve transportation sum based on VAM and MODI method when the problem is not optimal. Okay, this is the third video of a video series based on transportation problem incurring VAM and MODI method. The first one was based on when the problem is optimal. Then we did one on alternate solution. Now this is one where what if the problem is not optimal and they've asked you to make it optimal. Okay, so let us see how to solve such kind of, so again a very important topic from the exam point of view.
Okay, the question reads that a company has three factories A, B, and C with supply of 800, 600, and 1000, and it has four warehouses, warehouse 1, 2, 3, and 4 with demand 4, 5, 7, and 800. Number one, test the solution for optimality using modified distribution method as MODI method. Second, if the solution is not optimal, then find the optimal solution by modifying it and then find the minimum transportation cost. Okay, so now whenever you get such kind of a question, always remember first we'll have to find the optimality. If you get the optimality negative, any of the optimum value is negative, it means the sum is not optimal, and thereafter we can solve it using modifying it. Okay, chalo. So now let us see how to go with the sum, how to start with the sum. The very first thing, now in the question they've already given us the allocated cells. Okay, so what we do here is, whenever allocated cells is given, we will first find the rim condition. So I'll write here rim condition. Now the rim condition ka formula is number of occupied cell should be equal to m plus n minus 1. Number of occupied cell in the question they're giving 1, 2, 3, 4, 5, 6. Okay, if you can look, there are 6 occupied cells. M is 3, n is 4 minus 1, so 3 plus 4, 7 minus 1 is 6. So it is telling, therefore there is no degeneracy. Okay, so now I can start with finding the optimality, or starting to find the optimal solution. So I'll write here now testing for optimality. Now in order to test for optimality, what we'll do, the columns will be, you'll have your W and ABC. Secondly, we'll have the supply, demand, and we need two more extra column U and V. Okay, based on that we will see whether it is optimal or not. So what I'll do here is, now first we'll make the columns and then we'll continue with the sum. Okay, so this is the table which is already given in the questions. I've just noted it down with those values. Okay, I've noted it down with the values. Now what we'll do here is, the very first thing that we need to find is, see, we already did the rim condition because we have already, so there's no degeneracy. So now we need to find the value of U and V. So that will be U1, U2, U3 we need to find. In here V1, V2, V3 and V4. Okay, U1 will always be 0. So using the U1 ka value, I can find V1 and V2. The 12 minus 0 is 12. 6 minus 0 is 6. Now with the help of V1 I can find U2. So 6 minus 12 is negative 6. Now with the help of U2 I can find V3. So 15 minus 6 is 21. And with the help of V3, so I can find 17 minus 21 is 21, in the same way 70 minus 21, that is negative 4. And with the help of negative 4 I can find the V4. 7 minus is positive 11. Okay, once we have done that, now we will find for unmarked cell. So I'll write here for unmarked cells. Okay, I will have cell formula will be change is equal to cost minus U plus V. So let us check which are the various cells which are there, which are unmarked. The very one is AW3. So I have AW3, change is equal to that is 20 minus u plus the v is 21, so I get negative 1. Next is AW4, change is equal to 25 minus 0 plus 11, so 25 minus 11 is 14. The next one I have BW2, so BW2 का change is equal to 11 minus negative 6 plus 6, so that becomes 0, so it will become 11. Next is BW4, change is 12 minus 6 and 11, so minus 6 plus 11, that is 5, so 12 minus 5 is 7. The next is CW1, the change is equal to 9 minus 4 plus 12, that is 8, so that becomes 1. And last one was CW2, where the change is equal to 15 minus 4 plus 6, so it will become 30. Okay, the first question, see in the question they are giving you first, test the solution for optimality using MODI. So optimality wise we did the optimality, we got the value for unmarked cell. Now the unmarked cell has one negative value, Now the rule is, if in your unmarked cell, if any of the value you get is negative, it means the problem does not have an optimal solution. Okay, so now what we'll write down, we'll have to write down a statement that since there is a negative change, since negative change is there, therefore the solution is not optimal. And if I need to make it into optimal, I'll have to write, therefore loop need to be formed. So now in order to make the loop, okay, look at the negative cells. Okay, now look at this very carefully. AW3, look here again, AW3, this is my AW3. Okay, in AW3 there was negative value, so I will be looping it from here itself. Okay, now this is the place from where I will have to start the loop because it's negative. Now again the rule is we have to go if I'm going, I can go either way, I can go in any of the cross direction, but it has to move only up to the point where there is a allocated cell, and from there I'll have to make a loop over it. So what I can do here is, I can either go left side or I can even go bottom side mein. So what I'll do, I'll go from the left side. Now there is an allocated, but then there is another allocated here, so I'll take it till here. Now I will go down because there is an allocated. I can't go further because there is no, so I'll take a right, so I'll come here. I came to this point. Now there is, I can go down, but then it doesn't make sense because if I go down there is no looping here, so I'll have to go up and close the loop. So these are my 4 points. Basically these are the 1, 2, 3, 4 point of my loop. Wherever you have started that is plus sign. Now go in alternate, so minus, this will become plus, and this is minus. Now the rule is after getting this you need to find the change. So I'll write here the minimum negative value from minimum negative is 300 and 500. So the minimum value is 300, so I'll write minimum negative value is 300. Therefore the change is equal to 300. It means wherever there is plus, 300 gets added to it, wherever there is minus, 300 will get subtracted from it. Okay, so now we will make a new modified table. Okay, a new modified table exactly in the same order. Okay, so we'll make the same table here but with these new modified allocated values. Okay, chalo. So what we'll do first let us make the table and then we see how to go about with the sum. Okay, chalo. Now see, since we have made the loop, how to go ahead. See, I made the same table, how to go ahead. Now From first all the loop values we'll take. Now this is 300, but that's minus. So 300 minus 300 will become 0. So there will be no allocation now here. This is 100 plus. So 100 plus 300 the change. This will become 400 now. Now this first let us take these minus and then we'll check for the remaining part. Now there it is minus. So 500 minus 300, that is 200. Here it is 0 plus 300. So this will become 300. Now this value was not in the intercepted part, so this remaining all the values will remain as it is. So this is 500, this was 200, and this is 800. So other value remained as it is. Okay. Now once we get the new allocated, check for the rim condition again. So I'll check here. Rim condition is nothing but number of occupied cell should be equal to m plus n minus 1. So number of occupied is 1, 2, 3, 4, 5, 6. 3 plus 4 minus 1, so 6 is equal to 6. Therefore, there is no degeneracy. Now, if there is no degeneracy, I can now start with the u and v. u1 I will take it as 0. So with the help of u1, I can find v2 and v3. 6 minus 0 is 6. 20 minus 0 is 20. Now, with the help of V3, I'll be able to find U2. So 15 minus 20 is negative 5. Okay. Now with the help of U2, I can find V1. 6 minus 5 is 11. Now what else can I find? Now with the help of V3, I can find even U3. So 17 minus 20 is negative 3. And with the help of this, I can 7 minus is plus, so it becomes 10. Okay, so we were able to find u and v. Okay, now let us find once we find it, now we'll find for unmarked cells. So I'll take an extra sheet. So I'll write here for unmarked cell. Okay, formula is cell is nothing but we need to find the change, which is cost minus u plus v, to check whether we are getting an optimal solution or not. Okay, now check which columns are unmarked. So I can have AW1 where the change is 12 minus u is 0 plus v1 is 11. So which comes to 12 minus 11, which is 1. Next is AW4 where change is 25 minus 0 plus 10, so which comes to 15. Third one, BW2 where the change is 11 minus 5 plus 6, that is 1, so that becomes 10. Fourth, we have BW4 where the change is 12 minus negative 5 and this is 10, so that becomes 7. Fifth one, we have CW1 where the change is 9 minus 3 plus 11, so that becomes 11 and 3 is 8, and then we have 1. And last one, CW2 which is change is equal to 15 minus 3 plus 6, so that becomes 12. Now if you look carefully, all the values are positives. The moment we have all the values positive, it is an optimal solution. Since we have no negative change, therefore it is an optimal solution. Therefore our total cost is equals to, so for total cost we'll check here what values we have got. So it is 500 into 6 plus 500 into 6, then is it 300 into 20, so 300 into 20, Next is a 400 into 6 plus 400 into 6 plus we have 200 into 15 plus 200 into 17 and lastly 800 into 7. So 500 into 6 is 3000, 300 into 20 is 6000, then 2400 plus 3000 plus 200 into 17, 3400 plus 8 sevens are 5600. When you add up all these values, you should get the answer as 23,400. Therefore, my initial basic feasible solution in IBF is 23,400. So this is how you all had to basically solve a sum when the solution is not optimal. Okay, so we started off with the rim condition. We got the values of optimality. We found that there was a negative value. Since there's negative, we had to loop it. Okay, we got the value of change. We made a new table of optimality. We found it. Again, we check the rim condition and thereafter we check for the optimality. All the answers are positive. It means it was an optimal solution. Since it is an optimal solution, we can find the total cost. Okay, I hope everyone have understood that this is how you all had to solve the sum based on transportation when the solution is not optimal. So we'll have to make it optimal using the following methods. Okay, so I hope everyone have understood that. With that, we will be ending this video here. Thank you.